Europa, one of Jupiter's 4 largest moons, is a world that captivates the imagination of scientists and space enthusiasts alike. Roughly the same size as our moon, Europa has an appearance unlike any other moon in our solar system. Its surface is smooth and shining bright white, speckled with dark lines and patches of red. But beneath this icy exterior lies a much deeper mystery, one that could potentially answer the age-old question, are we alone in the universe? What makes Europa particularly intriguing is the possibility of a vast, liquid ocean hidden beneath its thick ice crust. In fact, scientists believe that Europa's ocean may contain twice the amount of water as all of Earth's oceans combined. This ocean is salty and thought to be in contact with Europa's rocky core, with various sources of energy likely contributing to the dynamic environment below. These are some of the same ingredients that scientists believe are necessary for life to exist. Europa's potential to harbor life is the focus of the Europa Clipper mission, a highly anticipated NASA project that is set to launch in the coming years. This mission aims to dive deeper into the mysteries of this moon and study whether it holds the conditions that could support life, perhaps microbial life, but still life nonetheless. The prospect that Europa may be hiding an entire ocean full of life makes it one of the most exciting targets in the search for extraterrestrial organisms. What makes Europa so intriguing is that while its surface conditions are incredibly harsh, beneath that icy shell things are very different. The surface of Europa is exposed to extreme cold, with temperatures plunging to an astonishing -160 degrees Celsius. These freezing temperatures make it nearly impossible for any form of life on the surface to survive. Furthermore, Europa has no protective atmosphere to shield it from the intense radiation emitted by Jupiter's powerful magnetosphere, which bombards the surface with radiation far stronger than anything we experience on Earth. This intense radiation would pose a significant challenge to life forms, potentially damaging their DNA and cellular structures. However, despite these hostile conditions, the true potential for life on Europa lies beneath the surface. Scientists believe that beneath the thick ice shell, Europa's subsurface ocean may be a more stable environment where life could thrive, protected from the damaging effects of radiation. The ice acts like a shield, providing protection for the ocean below, which is kept warm by a variety of energy sources, possibly even hydrothermal vents, much like those found in Earth's deep oceans. These conditions could be the key to understanding whether life could exist, or may have existed, on Europa. Exploring Europa, however, is no easy task. Its location in the far reaches of the solar system, combined with its extreme surface conditions, make it a difficult and challenging world to study. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, provided valuable data about Europa's surface, atmosphere, and magnetic field. However, this spacecraft could only perform brief flybys, which limited its ability to fully explore the moon's potential for life. More recently, NASA's Hubble Space Telescope made an exciting discovery, plumes of water vapor erupting from Europa's surface, suggesting that water from the subsurface ocean may be venting into space. This offers scientists a unique opportunity to analyze Europa's ocean without having to drill through the thick ice. This discovery has fueled great excitement within the scientific community. The upcoming Europa Clipper mission is one of the most ambitious missions ever planned to study this fascinating moon. Set to launch in the 2020s, the spacecraft will conduct detailed flybys of Europa, using a range of scientific instruments to investigate the surface, the icy shell, and the potential for life in the subsurface ocean. If microbial life exists on Europa, it may rely on similar processes, using chemical energy from Europa's core or from potential hydrothermal vents in the subsurface ocean. Europa's ocean may contain an environment similar to Earth's deep ocean floors, where life flourishes around hydrothermal vents. On Earth, these vents support diverse ecosystems of bacteria, tube worms, and other organisms that rely on chemosynthesis, the process of turning chemicals like hydrogen sulfide into energy. Scientists speculate that Europa's ocean might also host similar vents, creating an environment where life could survive, even without sunlight. This has become one of the most exciting hypotheses in the search for extraterrestrial life. However, the idea that more complex life forms could exist on Europa remains highly speculative. While microbial life seems to be the most likely candidate, some scientists have wondered whether the conditions on Europa could eventually lead to the development of more complex organisms. If hydrothermal vents exist on Europa's ocean floor, they might serve as the foundation for a growing ecosystem over time, with simpler organisms evolving into more specialized forms of life. Europa's potential to support life has not only captured the attention of scientists but also the imaginations of science fiction writers and filmmakers. From Arthur C. Clarke's 2010, Odyssey 2, where Europa is depicted as a place of mysterious alien structures beneath its ice, to the 2013 film Europa Report, which follows a fictional crew on a mission to explore the moon, Europa has become a symbol of the unknown. These fictional portrayals help fuel public interest in space exploration and emphasize the importance of scientific missions to uncover the truth about this fascinating moon. The idea of hydrothermal vents on Europa plays a central role in the search for life. On Earth, these vents are crucial for supporting entire ecosystems that thrive in the absence of sunlight. Europa's subsurface ocean, although much colder than Earth's oceans, could still have similar environments. Gravitational interactions with Jupiter could generate enough heat to power hydrothermal vents on Europa's ocean floor. These vents could provide the warmth and nutrients necessary for microbial life to persist in an otherwise frozen environment. If these vents exist, they could release organic compounds into the surrounding ocean, creating a rich ecosystem that sustains life forms. This idea represents one of the most exciting avenues of research in astrobiology and could potentially provide the breakthrough that confirms life beyond Earth. The exploration of Europa is a key part of humanity's quest to answer one of its oldest and most profound questions: are we alone in the universe? Europa offers scientists a unique opportunity to study a world that is very different from Earth yet still may share some of the same conditions that support life. The Europa Clipper mission will take us one step closer to understanding whether life could exist in environments vastly different from our own. In the distant future, there is even the possibility that humans could travel to Europa and study it up close. The extreme conditions on the Moon, radiation from Jupiter, the thick ice shell, and freezing temperatures, would present enormous challenges. However, the technology needed to make such a mission possible could revolutionize space exploration. A human mission to Europa could provide unprecedented insights into the potential for life on this moon, as well as test the limits of human space exploration. In conclusion, Europa is one of the most exciting and enigmatic bodies in our solar system. Its subsurface ocean, icy crust, and potential to harbor life make it an essential focus in the search for extraterrestrial life. Whether or not we find life, the discoveries we make on Europa will significantly expand our understanding of the universe, and the conditions necessary for life to exist. Europa represents not only a scientific frontier but also a symbol of the possibilities that lie in the vastness of space. As we continue to explore this distant moon,